So, in the last week we started with introducing the fatal 4 hazards. So, it starts from falls, cave-ins, caught in between or struck by, electrocution and so on. So, I also said we will be discussing each one of the hazards along with where generally it is seen along with the operation also we will be discussing. So, last week we have seen on falls and concreting work and demolition work, primarily in the scaffold and form work where the falls is predominantly seen. So, this week we will see on cave-ins, and excavation is one of the major operation where cave-ins are a real killer. Okay. So, if you talk about excavation, then cave-ins are the major hazard. We will also be discussing what are the other hazards available also. So, excavation as such I will be covering in this particular class. Now, why should you go for excavation? So, the top soil as such is not suitable for construction and it comprises of mineral matter, organic matter and so on. So, water, air, etc. So, that is why it is not really suitable for construction, and hence the soil has to be removed. I am talking about surface excavation, and deep excavation also generally happens to support a structure and its foundation. So, even the top soil has to be fully leveled and cleared, and also the separate holes or openings has to be made, earth has to be cut to support the structure and its foundation. So, when you say earthwork, it is not just one single operation. Okay. There are so many steps in the earthwork operation itself. Okay. So, as such if you start looking at there are some preparatory issues which implies before you dig, okay, and then you have to think of how do you dig. So, the choice of equipment and combination and so on. Then digging out, okay, how exactly you have to dig along with protection of sides and the shores until the foundation is completed, preventing from side collapse. Then whenever you encounter with a water table, dewatering or bailing out the water from the pit or the trench, then backfilling of the trench pit once the excavation or foundation is completed, and then you dump the surplus earth into some specified locations or a marked location. So, these are all the different steps you have in earthwork operations, and now we are going to see different hazards available in all these steps. Now, let us start with before you dig, what are the major precautions you have to take. Okay. And before understanding that, let us discuss about something on IS code and what they talk about types of soil and types of excavation. So, as given in SP 62, there are several types of soil, soft soil or loose soil. So, what happens here is examples are sand, gravel, loam, clay, mud, black cotton soil and so on. So, you can use ordinary digging tools like for example, shovel, spade or rakes for actually cutting off the earth. The next type of soil is hard or dense soil, example stiff heavy clay, hard shale or lime concrete. So, you may have to be very close in applying your energy and force, and so you may have to accordingly use rippers or something, because you may have to closely work on and loosen the soil so that you are taking off the earth. The next category is ordinary rock. Again in rock you have several categories. One is rock which does not require blasting, and the other one is where blasting is prohibited. So, in ordinary rock, so limestone, hard, laterite, then unreinforced cement, concrete, etc. So, all these are examples, and maybe you have to split with crowbars or picks. Hard rock which requires blasting, so any rock or boulders are the examples, and you can go with quartzite, granite, basalt, RCC are the examples of hard rock. You have to blast the ground in order to do the cutting of the earth. The next is hard rock, wherein blasting is prohibited due to some reason or the other. You can use chiseling, wedging or any other agreed method by the engineer in charge. So, what are the types of excavation now? Okay. Again, there are several words which comes in research and in industry practice, starting from structural excavation, bulk excavation, confined excavation, sloped excavation, and then stepped excavation and so on. Like this, there are a lot of terms coming in, but let us think about based on the protective measures which we have to follow in the construction site. So, accordingly the first category is confined or structural excavation. So, once your drawings are all completed, you give a good for construction drawing, and based on that drawing you actually cut the earth only to that portion. So, or it can be a trench excavation, or only for individual footings or foundations you cut the earth as a volume. So, you may use close cutting of earth only in specified locations, then that is primarily called confined or structural excavation. The next type is bulk excavation, wherein your quantum of excavation is voluminous and you may have to use several equipment like as shown in the figure here, several equipment, and which may be moving on in the site for cutting off the earth. Excavation in rock, for relatively hard rock you can use rippers or pneumatic breakers. For very hard rocks you can go for blasting operations. Okay, for example, this is a confined excavation. Okay, so this is like a trench excavation shown here. Okay, and this is actually a bulk excavation. So, here you can see it is a very large site and a bulk excavation. Lot of equipments will be available in the site as seen here for the work, and these are the excavation work in rocks. Primarily you have to use a ripper or a breaker or even drilling machines for cutting off and loosening the earth. Now, before you dig, okay, you have to post warning messages to the public, and you have to prevent the public from entering into the construction site. So, what you should do is first provide sufficient number of notice boards and other danger signals and warning signals to prevent the accidents. So, next one is barriers. Okay, barriers are primarily obstacles or obstructions, so that the public is not intervening in the excavation work, and this should be provided for any excavation shaft or pit or opening having a vertical distance of more than 2 meters. Then fencing. So, this is primarily a picture of fencing. So, fencing is actually erected for deep excavation and when there is lot of likelihood of public frequenting that area. So, the next precaution. So, first is you have posted a message, you have announced to the public, you have given enough warning signals on excavation is going on. The second precaution that you have to do is identify all the buried underground utilities. Okay, there are so many underground utilities which are buried inside the ground, and you may have to identify all of them, so that you do not mess up with those utilities when you are actually putting your excavator equipment there. Okay. So, all the utilities which are all passing through the site has to be identified before you start the digging, and so there are a lot of means of identifying also. So, utilities must be exposed before digging. The site engineer should identify the underground utilities using detectors. You can also use ground penetrating radar. There are other devices also available. So, you may have to use an appropriate device and an appropriate choice of GPR based on what you wanted to scan. Okay, you are actually scanning the ground, and you should know what exactly you have to scan and what is the depth of scan, what is the intensity or the accuracy with which you want to scan. Based on that, you may have to choose the equipment. Sometimes even your scanning measurements may go wrong. Okay, you may not be able to get a right data, or sometimes there may be some mystery obstructions present inside the soil and you won't know what exactly it is. Okay, so you should not be leaving that in doubtful. So, you can also do trial pits. So, trial pits can be done manually at several locations in order to identify those underground utilities. So, you can do a trial pit very close to those utility and watch for what is a utility, and once you are confirmed as what is a utility, then you can identify all the others and then go. Okay. So, always, even if the utilities are all found, or even if you think and you are confident that all utilities are identified, still you have to proceed with proper caution when you are doing the digging operation. And The work permit has to be obtained, okay, for either emptying the utility, provided it is a sewerage line or a water line or something, or diverting the route, or maybe de-energizing if it is an electric cable or something. So, you have to take adequate measures for from the concerned authority, and you have to divert or safeguard the site first of all the buried utilities, and then you may have to work. And all the workmen who are working in the site should wear a proper shoes, gloves and other PPEs as recommended. Suppose if you have identified or you have a suspicion on some underground electrical cables, then the cable should be de-energized. Otherwise also the equipment which you are using, for example tools like crowbars or spade, etc., they should be well insulated, so that the workers do not get an electric shock while they are digging those places. And the employees also should determine all the estimated locations of these installations, so that it is easy for them to divert and turn. Okay. Once you identified all the utilities, then the next step is you have to mark those utilities onto the ground. Okay. There are some color codes and color symbols for marking all those utilities on the ground. You can use a flag, okay, as shown in the figure here. You can either put color flags and then say that these are the lines where utilities are available, or you can also apply spray paints and then show that the utilities are available. Okay. And American Public Works Association APWA has recommended uniform color code, which is followed in several countries. Okay. White color is generally recommended for the proposed excavation, pink color for temporary survey markings, yellow color for gas, oil, steam, petroleum or gaseous materials, red generally is used to show electric power lines, cables, conduits and lighting cables, blue for potable water, orange for communications, alarm, signals, cables or other issues, purple for reclaimed water, irrigation and slurry lines, and green for sewers and drain lines. So, according to these color codes, you can mark and show the presence of the utilities which you have identified and traced out before you start with the excavation work. Now, the first step I told before you dig is, first you have to post adequate warning messages, signs, and then you may have to put proper barriers, fencing and so on. Second is identify all the underground utilities. The next step is, there may be adjacent structures close to your site. Okay. Your site may not be like too spacious that you do not have any neighboring structures close by. You will have so many neighboring structures close by. Okay. So, you have to analyze what are the neighboring structures close by, and you may have to see whether those the foundation of those neighboring structures are interfering with your excavation or not. Okay. And sometimes what happens, your site may be, you may be excavating some portion, it may be close to an foundation of another existing building, and suppose if you are taking out soil from a close by structure, that structure may start weakening and it may lose its strength. Okay. So, there are some ways of preventing that, and then only you have to start with your excavation work. So, no excavation work shall happen below the level of any foundation unless underpinning. So, underpinning is actually providing an additional support like this below the structure, so that the structure is not falling off. Or these are the pictures of shoring or shoring, etc., to prevent collapse of the structure or excessive settlement. So, the foundations adjacent to and below which the excavation is to be made shall be supported by either adequately designed sheet piling, shoring or any other agreed method until the excavation of this particular site is open. Okay. And these excavated materials also should not be piled against the walls of all these neighboring structures, because it can collapse. Okay. So, those buildings can also collapse, so that you have to take care of. Then the next step is site clearance. Okay. As I told you, you may have to first clear and level the ground before you start with your excavation. So, site clearance, what all you should think of. Okay. So, before site clearance itself, you should have some usable structures are there, some existing structures, some trees which you want to safeguard, some archaeological monuments, structures, etc., if they are there. then you should get proper permission for safeguarding that, so that your excavator or your excavation work is not bombarding with that. Okay. So, the site should be cleared of vegetation, trees, saplings, any rubbish which is remained up to a distance of 50 meters outside the clearance area, and the roots of the trees shall be removed to a depth of at least 60 centimeters below the ground level. Okay. So, that should happen, and the hollows of the removed roots and so on should be filled up with earth, leveled, rammed, and you should ensure that it has attained the normal compacted level. And the trees measured at a height of 1 meter above the ground level should be cut only after you get a proper permission from the engineer in charge. The existing structures, if they are all available, it should be safeguarded properly, and then only you should start with your excavation. So, many of the safety precautions starts from even before you start your excavation. Number 1, public safety should be ensured, that you have seen earlier. The hazards must be removed or supported before the excavation starts. Excavation sites should be protected or supported and to safeguard the employees, and take care when you are walking near excavation sites, because with the movement of vehicle, with maybe with the flow of water, or maybe with the dump of soil close by, the land may be slippery and you may be tending to slip or trip and fall. So, better you should be very careful when you are walking near excavation sites, and always try to barricade or cover any well, pits or shafts, and the employees must be trained to operate any equipment. And so, general precaution is when any lifting or digging equipment is happening, so do not go near that. So, stay away from the loads and stay away from vehicles which are loading and unloading. When mobile equipment are operated close to the edge of the excavation site, you should be stopping those processes, because a vibration of that equipment can actually disturb the soil which you have cut, and use appropriate PP. So, these are the steps which are like generic steps which you should keep in your mind before you start with your excavation. Now, let us talk about the actual excavation and where cave-ins are more. Okay. So, cave-ins are generally happens, one in trenches and other one is excavation, but generally trenches. Excavation trenches are considered to be number 1 killer in cave-ins. Okay. So, and let us now discuss what is a trench and what is an excavation. Okay. So, when any width of your cut earth is less than 15 feet, then it is primarily called as a trench. Okay. And if it is more than 15 feet, it is generally called as an excavation. Whether it is a trench or an excavation, they are all man-made cut. It is not a natural hole on the earth. So, primarily it is a man-made cut formed by removing some portion of the earth, and this excavation can be done maybe for a building basement or for a road bed and so on. So, what is a trench? It is a narrow underground excavation. So, primarily your depth of the trench is more compared to your width. Okay. As I told, so width is generally less than 15 feet and the depth is really steeper and steeper. That is primarily called as a trench. So, possibilities of cave-in are more in a trench compared to your regular excavation. So, that is deeper than it is not wider than 15 feet. So, trench cave-in fatalities is a major killer in construction. Okay. So, now let us see what is this cave-in fatalities and some statistics on what is this cave-in all about. So, some dirt facts, okay, because soil is considered to be dirty. Let us talk about some dirt facts. Most of the soil are at least like very heavy. Okay, soil is not lightweight. Okay. So, statistics says, 1 cubic yard of soil weighs around 2000 to 3000 pounds on any pace. So, 1 cubic feet of soil weighs almost more than 100 pounds. Okay. So, again the weight of the soil depends on type of material, amount of water and air contained in it, okay, and all the compaction levels and so on with which it has been disturbed earlier. So, all these are inclusive of the weight of the soil. Okay. Now, how is this soil falling on a worker is linked with? Okay. This 1 cubic foot of soil is equal to actually a weight of a car. Okay. So, imagine a car, a normal medium sized car. and just falling on you. Okay. So, that is the weight of the soil which will fall on the workers, and what happens is it takes very less second for the worker to react, okay, onto the soil which falls onto the worker. Okay. And if you see the statistics on death or fatality with regard to trenching or cave-in incidents, 37% of most of these incidents have occurred at depths, trench depths less than 5 feet. Okay. So, it is not too steeper on depth, but still many fatalities have happened. Okay. So, ironically, if you see the more deeper you go, there are not too many fatalities, or adequate safety precautions are already in place. Okay. Only for shallow depths of trenches wherein people take it very easily, there lot of fatalities have happened. Okay. So, many of the fatality has happened only when the depth of the trench is less than 9 feet itself, okay, not more than that. And most often during these fatalities, protective systems were not in place. Okay. That also you should understand. So, what happens is when this weight of the soil is on you, it can actually suffocate the victim and can also create bone injuries. So, compared to the death, there are many permanent fatalities, permanent disability also has happened to the workers. Okay. So, the trenches tend to collapse very quickly, leaving no time to react, but there are some warning signals which are given before a collapse happens. Okay. Ground settlement can be seen. Okay. Side walls you can see lot of cracks and minute movement or dislocation of some pieces of the earth. Pebbles or small pieces of soil can start falling, that itself shows a warning sign that this soil may collapse at any point of time. There can be changes onto the side wall from where you have cut. So, the cave-ins are possible when you are doing the cut of the earth. Okay. Why? Because see, when a soil is undisturbed, you have actually the pressure coming on the top and also the capillary action and other pressures coming on the bottom, and also the soil pressure which comes on all the sides. So, all this pressure tends to be equalized and the soil is actually very stable. Okay. The minute you start cutting the earth, what happens is some forces on this equal movement is disturbed, and as a result it starts collapsing and a lot of accidents starts happening. Okay. But if you are very watchful in the construction site for all these small signs of warning, then you can easily prevent accidents in the construction site. So, cave-ins can happen, but accidents can be prevented provided you keep proper safety precautions. Now, what is the statistics on fatality in trenching accidents? This is primarily from Bureau of Labor Statistics, which says 2011 to 2016, if you see, this is the trend of the accidents you can see here. So, there are quite a few fatality which has happened, and for almost this 2-digit number, at least a 3-digit number of permanent disability also is reported in several documents. Okay. So, there are quite a few fatality and quite a few major injuries or permanent disabilities have also happened as a result of collapse of soil. Okay. Now, what can be the reasons for soil instability? One reason I said is primarily you are disturbing a mass, and wherein there is you have all the forces intact and some forces are getting disturbed because you are just cutting the earth and taking it away. Okay. That is a other scientific reason, but there are other reasons also which can be man-made, which can create a soil unstable and it can start collapsing. The trench walls collapse when they stand unsupported for a long period of time. Okay. You are cutting the earth and the side portions are standing firmly. It won't be standing firmly for longer hours of duration. Okay. Maybe for some time it can stand, and before that you should put proper safety precautions so that it is all standing firm. If you leave the earth as such without putting a safety barrier or barricade in terms of shoring or shielding, then automatically it starts collapsing and it closes the trench opening which you have done. Okay. And before we discuss on what are the reasons for instability, we will also discuss when you are not you need not be bothered about side wall protection. Okay. No protection is required in a trench when the material is solid or stable rock and the trench is also less than 5 feet deep. Okay. So, the trench can go till 5 feet deep, you need not have a protection. If the soil is investigated as a solid rock or a stable rock, then you need not worry about stable or any safety protection, it can stand on its own. Suppose, okay, for everywhere you should know what can happen if something goes wrong. Inside anything can go wrong, especially with soil, anything is possible. If the soil type is not determined or it is difficult to identify what type of soil, then better to classify it as type C soil. We will discuss about type A, B, C soil after few slides. And when you have less than 5 feet, when you have gone, no, when you are just below 5 feet and so on, a competent person should actually start inspecting the excavation and determine whether there is no indication of a potential cave-in. Then you start putting in all your safety shields and barriers, and then you can go in ahead in continuing with your excavation. Now, let us come back to factors which actually which are primarily behind the instability of a soil. Okay. Number one is your soil which is excavated from the cut portion, which you are dumping in very close by. Suppose you use an equipment or excavator and start cutting out cutting the earth, you actually turn the boom and dump the soil in a little close by location. So, there are some guidelines as to where how much distance away from the cut earth you can dump those soils. So, always follow that guidelines. So, otherwise if the soil pile is very close by to the cut earth, so there can be imbalance load which can happen and easily cave-ins are possible. The next is vehicle which are passing by. It can be, suppose if you are close to a busy street or something, there may be movement of vehicle and your excavation can be disturbed with the movement of that vehicle, which can create vibrations and that can lead you to cave-in accidents. Other one is vibration, because you wanted to use some vibrators just to loosen the soil, that can also create lot of vibrations and the soil is loosened and obviously there may be a cave-in accidents. The next is your type of soil. Suppose if you have not identified a proper soil type and you have chosen a wrong protective measure for safeguarding the side collapse, then obviously it is not going to be a preventive measure at all. Okay. You identify the soil type as C, okay. You identify soil type as A and you have chosen a measure as something like a different one, then what happens is it is not going to safeguard. So, obviously you are going to be having an accident there. Depth of the cut, there are guidelines as to how, when the depth with which you have to go, you have to bring in adequate measures also. Okay. And after some level down, you may also have to think of fall in accidents. Okay. So, from the edge of the ground level of the pit or opening, person or vehicle, anything can fall down, that also you may have to anticipate. The next is saturation, that is through rain. Okay. Sometimes raining can happen and it may also start collapsing your soil, and as a result there can be a cave-in accident. Other one is natural capillary action, as a result of which the water table can be seen when you are starting to digging. That is also one of the reason for cave-ins accidents to happen. And the last one is buried utilities which are all available. Okay. Safety precautions. So, as I told you, the soil piles should be at least kept 2 feet away from the edge. Okay. And on either sides, and the material storage should be also at least 2 feet away from your edge. Okay. And there is something on 1 feet, 2 feet rule and so on. Let us talk about that this safety precautions. It is easy for you to remember in terms of numbers. Okay. So, excavated material should be kept away from the edge, always maintain the 2 feet distance on either side of the cut edges. Okay. And in special cases, if you are not able to dump it away from 2 feet because you do not have a proper place to dump in,
then you can have little closer one, but it should be not less than 1 meter, and also you should also be checking whether that particular land is able to support all your additional load just because of the cut earth. Okay. Now, the next is when a person or when a worker is inside the pit, okay, inside the excavated pit, he should be able to reach to a nearby access for evacuation, and the nearby access should be not more than 25 feet. Okay. So, whatever direction he is, not more than 25 feet, you should be able to see an access. The access can be in terms of ladder, ramp or stairs. Okay. And beyond 4 feet or deep, then the worker should not be entering unless there is a safe entry exit point. Okay. And if your trench pits are more than 5 feet or deeper, you should be looking for water accumulation hazards also. Okay. The next is types of soil collapse. Let us talk about the pattern of side wall collapse. Okay. That is what we have seen as one of the major danger. When you start cutting out the earth, the side walls tend to collapse due to several reasons. Okay. Number one is sliding. Slowly the soil particle can start coming down, sliding, and it can bury the worker, or toppling. There can be a cut along the sides, okay, and one portion of the earth can actually topple onto the worker, and there can be an accident. Tension cracks, there can be lot of cracks which can happen all along the excavated sites, and as a result it can start falling off onto the worker. The next one is bulging. Bulging is primarily bulging of the bottom portion of the soil, and the top portion of the soil is more bulged than the bottom portion, and as a result you have the earth to be fallen off. The next is heaving or squeezing. It is nothing but with the weight of the soil on the other ends, it starts coming down, and actually you actually find not a proper pit which is excavated, but actually a little bundled one. So, that is primarily called as heaving or squeezing. Now, what are the different measures of protective systems? Okay. So, whenever you are cutting out the earth, then you should be having lot of protection systems are available, and number one is shields, then shoring and sloping. So, shielding, shoring and sloping are the three methods of protecting any open pits or trenches and so on. Okay. So, this picture is primarily to show that actually the excavated material is lying too much away from your cut portion, okay, and you can see this pipe laying operation, and the excavated earth is it is not piled up all along the walls and little away from the walls. So, the employer shall select and construct the slopes and configurations for sloping and benching systems. We will discuss about what is a sloping benching system, for which you should know what are the types of soil, and accordingly the sloping and benching system we have to understand. And sloping and benching are supposed to be called natural ways of safeguarding the earth, and the artificial way of safeguarding the earth is either through shores or through shields. Shores are nothing but some panels or supports you keep onto the sides all along the cut earth to prevent the collapse. Shieldings are like trench boxes, okay. They are primarily called trench boxes, and they are like boxes which are just fixed all along there, and inside the box the workers can start working in. Okay. So, even if the collapse of the side walls happen, since you are inside the trench box, there is no fatality or accidents happening are really minimized. Now, let us talk about types of soil and also the sloping as a precaution for the collapse, or to prevent the collapse of soil. So, type of soil, so A, B, C are the three types of the cohesive soil. We are only going to talk about the cohesive soil. For any stable rock, you need not think of a sloping. Okay. Sloping is only to give a slanting nature of the soil cut. By nature itself, what happens is the soil cave-in will not happen. Okay. So, instead of cutting the earth like this, you are actually having a slope, so that your cut earth naturally will not yield and cave-in is not happening. Now, There are for stable rock which can stand on its vertical line itself, you need not think of a protective measure at all, you need not think of an angle also. Okay. So, for a stable rock, vertical is what is allowed, so it is 90 degrees. For type A soil, B soil and C soil, then the width to depth ratio and the slope angle all varies. For example, slope angle is what is given here. So, this is primarily a trench, okay, and if you see here, this is the portion for which you have to excavate. Okay. Instead of cutting out like this, you are actually maintaining a slope. Okay. So, for A, B, C, you have 3 different slopes, 34 degrees, 45 degrees and 53 degrees. Now, what do you mean by this? So, primarily if you maintain your horizontal width, that is 3/4, and your vertical as 1/4, this is for type A soil. For B, this will be 1 and this is also 1, and for type C soil, this is 1.5 and this is 1. Okay. So, type C soil generally happens like this, and this is actually your type B soil, okay, which is what is shown here. So, you will have a very low slopes for type C, and you will have little steeper slope for type A soil. One of the technique adopted in many of the sites where adequate area is available in the right of way to have a natural slope like this, and then to have a natural means of excavation protection, you should have so much of space. Okay, you should have so much of space. So, this is actually your cut portion. So, you should have all these width available all along your side, so that you can actually do this sloping. Okay. The slope angle have also to be maintained based on the type of soil you have identified. Suppose if you wrongly choose a soil, then you will not be able to have a proper protection. Benching, so this is primarily called benching, okay, and this is the sloping. So, this is sloping and this is called benching. So, benching is used only for types of A and B, and trenching with improperly sloped or unsloped trench walls can cause most of the fatalities. Now, let us see what are the A, B, C types. A is primarily clayey soil, silty clay, sandy clay and so on. B is angular gravel, silt or silt loam and sandy loam, and C is primarily gravel, sand, loamy sand soil, or soil which is where water is freely seeping away. Now, if you see here, this is also another picture to show on benching. Okay. For type B soil, you have to maintain 1:1. So, this is 1 and this is 1. So, this is how the benching looks like. Now, some precautions: recognize that soil types can change quickly, in the sense when you start digging out from the top level to next little lower level and so on, the type of soil can be really varied. Okay. So, evaluate the soil conditions periodically whenever you start cutting out the earth, and if the soil starts looking out different, then you have to really evaluate it, okay, and then you may have to identify. So, reclassify the soil if appropriate, and as I told you earlier, if you are not able to identify what is the type of the soil, better classify it as type C soil. Okay. The next, artificial systems, number one is shoring and the other one is shielding system. So, shoring is a system which can be adopted to prevent collapse of soil when there is no proper right of way available for doing your natural sloping process. So, it shall be ensured all the support work is secured, props and wedges are all tight, and the shoring can be installed from the top down and should be removed from the bottom to top. Okay. Actually, you have all vertical panels like this, okay, and you have all horizontal panels here. These vertical panels are called sheeting, horizontal one are called wales, okay, and there are lot of cross braces also to maintain the two vertical distance of the sheeting, and there are a lot of shores, okay, which are actually protecting through which the braces are handled. This is primarily called a shoring system, and this is a picture to show on the trench boxes or the trench shields. Now, let us see more on the trench shields. So, trench boxes, okay. So, these trench shields are like boxes, okay. They come as boxes and with which you have to put into the excavated portion. As you start cutting out the earth, you have to put these boxes inside, and the workers can actually start working inside these boxes, okay. Now, the next hazard which is seen in the construction site is water accumulation. Okay. So, what happens is naturally the soil is full of water up to the water table, and the soil above the water table also has some water because of capillary action and so on. Okay. Water as such is very hazardous because it makes the soil slippery, and hence it is very unstable to be working on in the site. And employers must not work in excavation where there is accumulated water or where there is water which is accumulating. So, dewatering has to be done before you start working on excavation. You may have to have adequate dewatering equipment along your site, so that you have to be using it immediately to drain out or pump out all the water. And the excavation which are subject to heavy rainfall should be inspected before you start putting in the equipments and continuing with your excavation work. That also you should take care of. Now, the groundwater control, the process of temporarily dealing with the groundwater to allow the excavations to be made in dry and stable, so that you can continue with your excavation. Now, there are two ways of controlling water. Number one is temporary exclusion and the other one is permanent exclusion. So, what is temporary exclusion? So, temporary exclusion will help you to prevent water or water seepage into the construction site till the foundation is over, and then those protective measures are all removed. In permanent exclusion of water, the water is permanently sealed off into the building or structure even after the construction is completely over. Okay. For example, metro construction. Okay. So, it is not only during the construction, there should be you should be safeguarding water ingress into the site. Even after the metro station is opened and it is operational and maintenance period also, you should be seeing to that no water is entered into the structure. So, it is like permanent sealing of water entering into the site, okay, into the site premises. In temporary exclusion of water, what happens is maybe for a pipe laying or canal, till the construction or laying of pipes is done, you actually prevent water from coming in, and once your structure is maybe your foundation work is done, then you do not bother about water entering into the construction site. In the sense, once your foundation is very strong and stable and it can support the load, then you are not worried about that. So, it is primarily you remove all those temporary precautions. Two main philosophies of groundwater control, one is like exclusion and the other one is called pumping. In the sense, exclusion is permanently you keep a barrier and remove, otherwise you use pumps or other sucking measures of taking out the water from the site periodically. Okay. Examples for all these dewatering techniques for temporary and permanent ones. So, temporary you can think of easily some pumps and so on. For permanent measures you can think of what is it called, diaphragm walls, or maybe you can think of well point systems. Okay. Well point system is very good for temporary means of removing water from the construction site. Now, you have to do inspections of excavations as the excavation work is going on. So, a competent person or a site engineer or site supervisor has to make daily inspections or periodic inspections on the work. Under certain circumstances also he has to be doing this inspection regularly before the excavation starts, and as and when it is needed, maybe after a heavy rainfall or maybe after an incident or an accident, you have to be really checking on the site conditions. After rainstorms, high winds or other occurrence, so there you may have to do the inspection. When you can reasonably anticipate an employee will be exposed to hazards, then also you should be thinking of inspections. If a competent person finds evidence of a possible cave-in, then you have to be doing the inspections, and those under such scenario the exposed employees must be removed from that hazardous area, and until the necessary precautions are put in place, they should not be allowed to return back. Okay. Now, duties of a competent person. So, pre-inspect the site and develop a safety plan, communicate and inspect for worker safety, and design proper access for employees and for the equipment. Determine the soil condition and select a protection system, whether it is sloping, shielding or shoring systems. Monitor the environmental conditions for any rain or something happening, then you should not be taking up serious or severe activities. Must have the authority to take appropriate corrective measures when something goes wrong and oversee all tasks being performed. So, this competent person or a site engineer, he should be available at all times when the excavation work is going on. And they have to also remove any workers who are not protected properly or who do not have a proper PPE or who are not in a proper safe place inside the excavated pit. Observe the protection when it is installed also, and remain present during the complete excavation, and remain present when workers are in the inside the trench. Okay. And these people also should be able to identify hazards, which implies the potential for a possible cave-in, and they have to be vigilant with all inspections also. So, prior to beginning the work each day, during the work as needed, and after a rainstorm or any other natural calamity which has happened, and any conditions exist which might lead to a cave-in happening. Now, so far we have talked about the before you dig, primarily the preparatory processes. Then we have talked about the different types of soil, different types of excavation also, and we also have discussed about the different protective measures for preventing the collapse in the trenches. So, it is primarily the sloping or benching, then shoring and also shielding, and we also have talked about what is trenching and excavation. So, that also we have discussed, and some statistics on the accident possibilities and so on, and some tips or safety tips when you are actually doing your excavation work. Okay. And last we have talked about what are the hazards with regard to water, and now we will move on into equipments related to excavation work. So, whenever you talk about excavation work, manual methods of digging the earth is no longer valid. Okay. Still small construction sites, it is still a practice, but in very large construction sites and especially for bulk excavation work, generally excavating equipments are often used, and these excavating equipments are too many in number, starting from backhoe, shovels, drag lines, clamshells and so on. Backhoe is nothing but which has an arm, the bucket or the grab, it is actually towards the equipment. In shovels it will have a bucket or a grab which is like away from the equipment, and drag lines are like you can see it is like actually like a tray or some sort of a setup through which it takes out the soil and do lot of the dredging operations. Clamshells and drag lines are generally used in places where there is water table seen, okay, primarily in a waterlogged areas. And clamshells generally has a bucket type of an approach through which it can start, it is like two arms which are fitted like a hinge, okay, with which it starts digging out the soil and it starts dumping away like this. Okay. And drag lines are something like which actually drags through lot of ropes and other supports, okay, and bulldozer and so on. Like this you have so many equipments. So, now let us talk about safety precautions with the earth moving machinery, primarily with the earth cutting machinery. So, number one is power shovel and number two will be bulldozer. So, these two safety precautions we will discuss. So, in power shovel, so there are two parts, one is nothing but this boom, okay, this is primarily called as a boom, and this is the bucket or the grab. Okay. So, we will be talking only about these two issues. Boom, the boom should be shall be prevented from accidentally swinging during the operation or transport, and it should not be pulled out very tight, okay, when the emergency stops are happening. Again it should not be swinging or moving ahead and hitting on someone. So, the boom should be intact at every point of time, and the maximum boom length and the maintenance issues of the boom of the equipment all should be as per the manufacturer guidelines. Now, what about the bucket or the grab? So, primarily the bucket or the grab load as planned earlier should not be overloaded at any point of time, and while operating the power shovel, the driver shall ensure that no person is working, walking or passing by under the raised bucket or grab, and the bucket or grab of a power shovel shall be prevented from accidental dipping, tipping or swinging operation, and the bucket or the grab of the shovel shall be pulled out of the bank as soon as it is full, and when it is not in use, the equipment should be on level stable ground and should not be left hanging, and the bucket or the grab shall be fixed to restrict the movement even when it is during repairing position. Now, next is bulldozer. So, there are bulldozer actually has several types of blades. Okay, it consists of several types of blades, like for example, straight blade, angle blade, universal blade, cushion C blade, like this are a lot of blades available. So, you have tilting, pitching and angling movement. Tilting is the blade can move along these two directions, okay, and pitching is this is the blade and it can move along a curve. Maybe when you are having a curved part of an excavation, then the equipment can be, the blade can be pitched so that it is actually going in a curved path. So, you can tilt the angle of your blade cutting. Angling is actually the curves or angle with which the blade, with the cutter blade is actually cutting the earth, and pitching is the movement too far or too close to the equipment. Okay. Now, when the equipment is moving uphill, the blade has to be kept low, and when the equipment is running down the hill, the bulldozer has to be in the lowest gear, and the blade shall not be used as like a brake in terms of emergency. Okay, like putting the brake into the blade into the ground, it should not be left as like an emergency stop or something. Okay, and when the work is closed out, the bulldozer has to be kept on a level ground, and before leaving, the driver has to put the brakes and check whether the equipment is in a stable position and so on, and then only he has to leave the place. There are some unsafe acts which you can notice in the sites. For example, a worker standing between the loads, okay, and as seen here, or a worker standing in a blind spot. So, actually the driver may be sitting here and the excavating work may be happening in front. So, his concentration may be only in the front portion, okay, and there are workers who are actually standing behind the equipment or primarily like a blind spots. Blind spots are not that visible in a heavy equipment. So, these blind spot works should be avoided, and these buckets are nothing but like transporting place. So, the workers are not supposed to stand or move anything by standing onto the bucket or the grab. So, practice safe excavation techniques and work practices, and read and follow all warnings on the machinery whatever is given, and to prevent overturns, most overturns occur onto one side, and also if a front end loader is mounted, then keep it as low as possible. Always remember, if you are not comfortable, especially when you are on a slope, then the slope is too steep or something, so it is not safe at all. Next, we will talk about overhead lines, electrical lines. When you are operating all these excavating equipments, most of them have a boom and a bucket grab. Okay. So, when the movement happens, it actually touches on, it is actually swinging and moving in the air. So, accidentally it may get interfering with some of the electrical lines which are passing by that area. Okay. And there is something called clearance, which implies the minimal distance of this equipment or the grab with actually all these electrical lines. Okay. And as per the IS code, the guidelines is for 11 kilowatts and below 1.4 meters, 33 kilowatts and below 3.6 meters, 132 kilowatts and below 4.7 meters, 273 kilowatts and below 5.7 meters, 400 kilowatts and less 6.5 meters clearance is supposed to be maintained. If the clearance is, you do not have an adequate place for clearance and it is less than specified, then it should be ensured the power coming onto the power lines is shut off or de-energized, and then only you should go for operating the machinery. Okay. While you are working with a site wherein there are underground electrical cables, also adequate precautions should be taken for while you are digging out the earth with those power cables beneath. The next is there are other hazards, primarily when you are cutting the earth. Last week we have talked about fall hazards. So, fall hazards, there we have discussed fall from a several floor above onto the ground level. Here also fall happens from the ground level into a depth which is below the ground level. Okay. So, it can be fall of person, it can be fall of material, it can be fall of equipment also. Okay. So, IS codes have given some guidelines as to some safety precautions to prevent these fall of person and materials. So, hard barriers or earthen bund, warning signs, warning lights shall not be provided to prevent fall of person or vehicles inside. Crossover bridge with guardrails shall be provided across the trench for the local people and animals. So, you should prevent the entry of someone falling into the pit like how it is given here. Ladders should be used, this I will show it in the next slide, used to enter or leave the excavation, and the ladder shall extend 1 meter above the ground level. The sides of the excavation shall be provided with benching or maybe benching to prevent the rollover of materials, and the materials shall not be stored or moved so closely to the edge of the excavation that they may fall down. For fall of vehicles or equipment before that. So, this is the ladder which I talked to you in the previous slide. So, at least 1 meter above the ladder has to extend. Okay. This is primarily for workers to climb or escape in terms of an emergency. The heavy equipment and vehicles shall be kept back from the excavated sites at a distance of not less than the depth of the trench. So, they should be really away from the excavated site. An adequate and well anchored stop block, okay, should be provided on the surface to prevent these equipment by accidentally running in and falling into these pits. The trench shall be provided with hard barricades, and visibility and safety also should go hand in hand. So, primarily these vehicles should be properly cleaned, free from scratches, or if the broken or missing or cracked glass are there, they should be replaced and repaired. So, that visibility of the operator is clear at all times and there is no compromise on visibility. Now, general precautions on earth cutting machinery and general precautions on transporting machinery, primary on tractors and dumpers, okay, are all I am not covering here, but they are all given in the IS codes. For example, let me talk to you on what are these equipments. So, when you see any construction site, especially with terms of earth cutting operation, you have an equipment for earth cutting. Okay. So, there is equipment only for cutting the earth, okay, and there is an other equipment for loading this cut earth onto an dump truck, and there are lot of dump trucks and other trucks for pushing all the earth into a specified location and dumping it somewhere. Okay. So, you will have 3 types of equipments whenever you are doing an earthwork operation. One is for cutting, other one is for loading into another equipment, and the third one is for transporting into the site. So, as such you will have different combinations of equipment, and some equipment can do all the cut, load and hauling operation. That is how it is termed in a construction site. Okay. Earth cutting, earth loading and earth moving operations. Okay. Accordingly, we will have so many machinery combinations available, and based on whether it is surface excavation or confined excavation or bulk excavation, the choice of machinery also varies, and accordingly the safety precautions has to be maintained. Now, with this the major part of the lecture is over. Now, a small recap on what we have discussed. So, trench safety by numbers, this is one of the picture which I liked on infographics. So, okay, 3 feet minimum distance, a ladder must be above the trench box or grade. 2 feet the minimum distance of a soil pile must be set back. Then 10 feet vertical distance required from 50,000 voltage power lines. 4 feet the depth beyond which a ladder is very compulsory, and beyond which air also is maybe toxic. Okay, you have to look for the contamination in the air, and also the air quality checks has to be done. Below you go for 4 feet down, and 5 feet onwards protective systems becomes mandatory. Okay, you have to think of shoring or shielding systems. And the next is 6 feet and down, you have to really look for fall protections, So, the workers have to have all the fall protection means, and also you may have to have guardrails above your pits. Okay. So, let us assume this is your ground level, okay. You are starting to go deep, okay, go in depth. So, when you cross below 4 feet, then what happens, ladders becomes compulsory. The minute you start going 5 feet down, you have to have all the protective measures, like for example, shoring or shielding. Okay. When you go below 6 feet, all fall protections has to be provided. Okay. Workers has to have lanyards and other systems, and this also should have a barricade, sorry, guardrails. Okay. And 20 feet is a maximum depth wherein you can think of shoring, sloping, benching and so on, and 25 feet you may have to have horizontal distance for means of egress. Okay. So, this is a chart on different numbers, so that you will be easily understanding what is there if you want to prevent accidents. And there are also lot of OSHA fact sheet and quick cards on working safely in trenches and doing the excavation works safely. For example, never enter a trench unless it has been properly inspected by a competent person. Cave-in protection measures are in place, and there is a safe way to enter and exit. Equipment and materials should be always away from the edge, and the trench is free of standing water and atmospheric hazards. Prevent trench collapses. So, trenches 5 feet or deep require a protective system, and trenches 20 feet or greater will require a protective system which is primarily designed by a professional engineer. Protective systems, slope or bench, shoring and shielding are the 3 protective systems which are available in place. Okay. Then so based on the type of soil, so you may have to choose your slope angles or your bench angles, and when you are going for benching, only type A and B soil you can do, you cannot think of type C soil. Okay. So, this is primarily a shouldering system which comes with timber, aluminum and lot of hydraulic jacks, and this is a shielding which is nothing but a trench box. The trench box picture is shown here. Okay. And always follow a 2 feet clear distance on the edges, okay, clear width, and do not deposit in any sort of excavated material or your equipment, nothing should be seen there, and a safe way of exit must be provided within 25 feet of workers in a trench. Okay. So, these are all like a recap as to what I have covered so far. Okay. So, again what are all the different hazards available? Underground utilities, overhead power lines, then excavated soil or collapse of soil, groundwater seepage, fall of vehicles, fall of equipment, fall of person, electrical shock hazards, fire hazards, rotating parts of these moving machinery, pre-existing structures. So, these are all the different hazards available. Okay. References, I have picked up these material from OSHA subpart P and also from IS 3764 excavation work code on safety, and also safety for working with construction machinery and guidelines for dewatering during construction. Thank you. Bye.